The last section in this chapter deals with complex numbers, and they're called complex, but they're not, and that sounds like they should be hard, but they're not really hard. They're also called imaginary numbers. You'll hear me call them imaginary numbers more than anything else. And if you were sitting in my on-ground class, you would have seen my cute little shirt that I wear, because I wear a shirt on Imaginary Number Day that says square root of -1, heart, math. And I wear that to remind you of one of the things that you're just going to have to memorize about imaginary numbers, and that is this rule right here. The square root of -1 is equal to I, which stands for imaginary number. In the first, I want to say it's the first section that we did in this chapter, when we first started talking about radicals, we talked about how you can't have a negative underneath an even root. We said that that was not a real number. Well, today you're learning what not a real number means, because not real numbers would be imaginary numbers, and they're indicated with the letter I. So in this section, when we come across a negative under a radical, it's going to come out of the radical as an I, and then we'll deal with the number part. So that's the first thing you need to know. Second thing you need to know, if we are doing any kind of computation and we come across an I squared, we are going to replace it with a -1. So I squared equals -1. So you can see that my square root of -1 heart math, that would be I heart math. I love math. Okay, so here's a couple of examples. If I have square root of -49, the negative is coming out as an I, and then since 49 is a perfect square, that comes out as a 7. That's how you end up with 7I. I'm going to come over here and work the square root of -8. Well, the negative comes out as an I. For 8, perfect square that goes into 8 would be 4. The 4 comes out as a 2, and a 2 stays. So a 2I came out, and a square root of 2 stayed underneath. So you can kind of see how we're going to be working these. We're going to work the simplification of the numbers and variables just like we did in an earlier section. But if we have a negative, we're going to have to deal with that negative as an I. So let's look down at some of these examples. The square root of -121. Well, the negative comes out as an I, and the square root of 121 is 11. So that will be 11I. Square root of -3, the negative comes out as an I, and you can't take the square root of 3. So I write I square root of 3. Now here's something I want to talk to you a little bit about. I always put my I's in the front of my square roots or cube roots or whatever we have. Generally going to be square roots with the I's. I put it in the front because sometimes if you put it at the end, it looks like it's underneath the square root. And you notice that on the end of my square roots, I always have that little tail, just so I can differentiate about what's underneath the square root and what's outside the square root. So I'm just careful that way. All right, this next one, I've got -32 underneath there. So the negative comes out as an I. The biggest perfect square that goes into 32 is 16. So the square root of 16 is 4, and the 2 will stay. So this is going to be 4I square root of 2. The imaginary number day is one of my favorite days in math class. I love it when we have imaginary number day. All right, now, if we are going to multiply, when you multiply, you need to take care of the I parts first. Before you multiply. You can't just say the underneath times the underneath like we did in the section that we did on multiplying roots. You need to take care of the I's first because you won't get the right answer unless you simplify the I's and then do your multiplication. So if we're looking at this B, if I'm going to do 4, square root of -4, that's going to come out as an I. The 4 comes out as a 2, so I have a 2I. On the -81, negative comes out as an I, 81 is 9. So that's times 9I. Well, that would be 2 times 9 is 18. I times I is I squared. You treat multiplication just like you would on any other exponent. But then remember that rule up at the top where I said if we come across an I squared equals -1. So that means I've really got 18 times -1, which is negative 18 for my final answer. On this division one, if you bring out the i's, I've got an I on top and an I on the bottom. If you have an I on the top and an I on the bottom, then those i's would cancel each other out. So then I've got 81, and remember I always said on division, check your numbers and see if they'll divide. 81 divided by 9 is 9. Square root of 9 would be 3. So that one comes out as a 3. There's no i's left in it. Negative 3 square root times negative 3 square root. Bring out the I in each one. I can't take the square root of 3. So I'm going to have I times I, which is I squared. Square root of 3 times square root of 3 is square root of 9. Remember, I squared is a negative 1. Square root of 9 is 3. So I end up with a negative 3 for the answer for that one. All right, this last one, bring out your i's from underneath the square root. And again, because I have one on top and one on the bottom, I'm going to cancel those out. Then 32 divided by 2 would be 16, and so that equals positive 4. All right, the next little chart down at the bottom of the page is not something that you're going to have to worry about. It talks about using this chart for powers of I. I'm going to show you how to do powers of I on the next page, and I'd rather you do them my way than do the counting like this little chart shows you. So if we look at the next page, you'll see powers of I. You can get really big, like I to the 476. So that seems like it would be pretty daunting to take I to that high of a power. But remember the key thing, I squared equals negative 1. That's what we need to know. So what I want to know is, can I turn 476 into a power of 2? Well, 476 divides by 2. So I could rewrite this, and this is what you're going to do on these powers. Rewrite them as I squared. So that would be I squared to the 238th power. Okay, still seems pretty big, but remember, I squared is negative 1 to the 238th power. Well, remember that 1 times 1 times 1 times 1 times 1 forever is still going to get a 1. So I need to think about my signs. I have a negative 1 to an even power. So that means I'm going to have a positive 1 for an answer. If I had had a negative 1 to an odd power, I would have had a negative answer. All right, before I do these odd ones, I want to come over here to I to the 38th. 38 divides by 2, 19 times. So again, I'm going to replace I squared with negative 1. This time I have a negative number to an odd power, so it's going to stay negative. So that's how you deal with that. Now let's look at I to the 65th. Now here's a little hitch. 65 doesn't divide by 2. But I can still work with it. What if I said that I'm going to split I to the 65th into I to the 64th times I to the 1st? Similar to how we split up variables with exponents when we're going to reduce and use square roots. Now 64 divides by 2. 64 divided by 2 is 32. And then I still have times an I out to the side. Well, that's negative 1 to an even power. So a negative 1 to an even power comes out to be positive times the I. 1 times I is I. So you get an I for that one. This next one is 95th power. So we're going to do the same thing. I'm going to make it 94 times I to the 1. Now 94, oops, sorry, I left my 2 out. 94 divided by 2 is going to be equal to 47. And so this time I'm going to have a negative 1 to an odd power, which is going to keep it negative. So I have a negative 1 times I, which is negative I. So here is the key on these higher powers of I. You've got a 25% chance of getting it right if you guess, because all of the answers are going to be 1, negative 1, I, or negative I on the higher powers of I. So it's up to you. If you want to learn how to manage them by turning them into powers of 2, that would be the best way to do it. Okay, let's look at definition of a complex number. And remember, complex numbers are just imaginary numbers. The standard form when we are writing these is to write the whole number part plus the imaginary part, or minus if it's a negative. But you write the whole part plus then the imaginary part. So down at the bottom of the page, I'm just going to do a couple of these. The real part is the 3, the imaginary part is the 4i. On the B part, since there is no whole number part, the real part would technically be a 0. The imaginary part would be, 47i. Okay, so that's how you, and this is just a way to write them. You need to write them. So on the next page, we're going to do some multiplying or some adding and subtracting. And when you do your final answer, you need to give it in standard form. So pay attention, especially when we start mixing up adding, subtracting, multiplying, dividing. Pay attention. When I have a symbol in between two parentheses, that means I'm going to either add or subtract. And adding or subtracting, we're going to collect like terms. And you're going to collect like terms with i's just like you would with normal variables. We do not change our exponent when we collect like terms. So we're just going to collect like terms. So in this one at the bottom, I've got 4 plus 1. That would give me a 5. I've got a negative 9i plus an I. That would give me negative 8i. And it's just as easy as that. In this next one, I don't have another whole number part besides the negative 1, so I'm going to list it first. Negative 4 plus 5 would give me positive 1i, or you can just write an I. Now you're going to need to be careful on this next one because it has a minus in front of there. So I'm going to rewrite it without parentheses, and when I do that, I'm going to have to change the signs of what's in that second parentheses because of that negative in front. I distributed that negative. So now I've got 14 minus 1, which would be 13, and I've got negative 8i minus 2i, which would be negative 10i. And then the rest of them are pretty self-explanatory. They're not going to get real hard on the homework. So let's move down to where we've got some multiplying ones. All right, let's do some of these multiplying ones. On the multiplying, we're going to do it just like we would multiply a normal binomial. A lot of times you're going to use FOIL. All right, had a little bit of a pen malfunction. Let's go back to multiplying. We're going to FOIL these. So first times first would be 1 times 5, which would be 5. Outer times outer would be 1 times 6i, which would be a positive 6i. Inner times inner would be a negative 2i times 5, which would be negative 10i. And then last times last, negative 2i times 6i would be negative 12i squared. And then it's a matter of simplifying. I've got a 5. I've got 6i minus 10i. That would be negative 4i. And then remember that I squared is negative 1. So negative 12 times a negative 1 would be positive 12. And then we're just going to collect like terms one more time. 5 plus 12 would give me 17 minus 4i. So pretty straightforward. Let's look at this next one. We're going to FOIL it again. Negative 1 times negative 1 gives me positive 1. Outer times outer, negative 1 times 10i gives me negative 10i. Inner times inner, negative 2i times a negative 1 gives me positive 2i. And then last times last, negative 2i times 10 is negative 20i squared. So again, we are going to, whoop, there goes the pen. We're going to collect like terms. So 1 minus 8i, and then that's going to be a negative 20 times a negative 1 is plus 20. So I get 21 minus 8i. So pretty straightforward with the multiplying. A lot of it is a FOIL. Let's do this one that's on the next page just to do one more. 3 times 3 would be 9. Outer times outer, 3 times negative 2 would be negative 6i. Inner times inner would be negative 6i. Last times last will be positive 4i squared. So we have 9 minus 12i, and then a positive 4 times a negative 1 is negative 4. So that's going to be 5 minus 12i. Pretty straightforward. All right, last part. When we get down and we have division, remember that when we had division with radicals, you could not leave a radical in the denominator. Well, the same holds true for imaginary numbers. You cannot leave an imaginary number in the denominator of a fraction. So in order to do that, you're going to have to rationalize the denominator. And we do that by multiplying by the conjugate. And remember, conjugates look exactly the same except for the sign in the middle. So for example, down at the bottom of this page, we've got 3 minus 7i over 1 plus 4i. So the conjugate of 1 plus 4i would be 1 minus 4i. So I'm going to multiply. I have to do whatever I do on the bottom, I have to do to the top as well. So on the top, we're going to FOIL. And you're just going to simplify as much as you can, just like we simplified on the multiplying that we just did. On the bottom, though, you should end up without any i's once you have multiplied by the conjugate, because that's the whole point of doing it. So on the top, first times first. So I've got a 3. Outer times outer is going to be minus 12i. Inner times inner is going to be minus 2i. And then last times last is going to be plus 8i squared. Then on the bottom, just messy, this pen. First times first, and since I'm multiplying by conjugates, I really just have to do first times first and last times last. And that's going to be minus 16i squared. All right, on the top, I've got 3 minus 14i, and then remember I squared is a negative 1, so that's going to turn that into a negative 8. On the bottom, I've got 1 minus, and then 16 times a negative 1, that's going to end up being plus 16, because negative 16 times a negative 1. So on the top, 3 minus 8 would give me negative 5 minus 14i over 1 plus 16 is 17. Now that's one way you could write it. I know one of the homework tools likes you to write it as 2 separate fractions, so you could write it as negative 5 over 17 minus 14i over 17. Either answer would be correct. Okay, let's do one more of those. I've got a 1 plus I in the bottom of this next one, so I'm going to multiply by 1 minus I. So I'm going to do that on the top. So first times first is 5, outer times outer, negative 5i, inner times inner, negative 1i, last times last, minus I squared. Really, the key is you've got to watch your signs when you plug in your negative 1 for these I squared. So on this one, first times first is a 1, and then last times last, minus I squared. I don't know why that keeps doing. That keeps just going crazy. Minus I squared. Okay, so on the top, I've got 5. I've got a minus 6i, and then I squared is negative 1, so I have minus a minus 1, which turns into a plus 1. On the bottom, I have 1, and then minus I squared turns into a negative 1. Again, minus a minus 1 turns into a plus 1. So I have 6 minus 6i over 2. Now, let's talk about reducing. A couple of different ways you could reduce. The previous one, we had a 5, a 14, and a 17. None of these numbers in this problem over here on the left have a common factor. So there would be no reducing in this one. On this, here's one way to reduce it. Remember how in the one previous we wrote it as two separate fractions. So let's do that. We could do 6 over 2 minus 6i over 2. Now, you can reduce each of these. 2 goes into 6 3 times, so I end up with 3. 2 goes into 6 3 times minus 3i. There's one way to reduce. Okay, so split it up into two fractions. And incidentally, one of the fractions may reduce and one might not. And that's okay. You just reduce what you can reduce and then leave alone what you have to leave alone. This second one, the second way to do it is what I call an all or nothing. If I look at my fraction and I've got all of these leading coefficients dividing by the same number, then I'll do an all or nothing. All of those coefficients divide by 2. So if I did an all or nothing, I'm going to divide each coefficient by 2. That would give me 3 minus 3i over 1, which reduces to 3 minus 3i. You get the same answer. I will take either one on a test. If Alex were to, or any of the homework tools were to mark you wrong, and I can go back and look and see that you wrote it either way, I'm fine with that. But if it does reduce, you probably need to try and reduce it. Be sure and email me with questions. Y'all have a wonderful day.